Okay guys, welcome to your video. Tonight's video is over exponential functions. So far in algebra we've learned about two different types of functions. We've learned about linear functions where the exponent is 1. We've learned about quadratic functions where the highest power in that function is a 2. And now today we're going to talk about a third type of function which is called an exponential function. As you can see on your screen, I'd write down this definition. An exponential function is a function in which the independent variable appears in the exponent. So let's think back. Independent variable is x. We always know that x is our independent variable. So when x is in the exponent of a function, we have an exponential function. Let's look at an example of that. An exponential function has the form f of x equals a times b to the x. A cannot equal 0, b cannot equal 1, and b has to be greater than 0. Those are all important things you need to note. Okay? Notice where our exponent is. Our variable x that we're always concerned with is in the exponent now. So here I have this function, f of x equals 200,000 times 0.98x, where x is the time in years. That models the population of a city. We want to know when will the population be, what will the population be in 7 years? So I know that my 7 is my years, which it told me in the instructions is x is the years. So I'm going to figure out what will the population be, that's f of x, when I plug in 200,000 times 0.98 raised to the 7. So I'm going to pull up my graphing calculator and I'm going to, let's see here, I'm going to type this in. I have 200,000, you know what, times, so in parentheses, let's see if I type that in right, 200, I think I did way too many zeros. Let me go back. What I'm going to actually do first is I'm going to do the 0.98 first, 0.98 raised to the 7. So I use my caret button, raised to the 7th, that's how I get that exponent, figure out what that is. Then from there, I'm just going to press times 200,000. So 200 and then 0, 0, 0. There it is. Press enter, and what does that give me? 173,625. Since we're talking about people, I'm going to round that 0.1. Since we can't have 0.1 of a person, I'm going to round that up to 173,626 people. Will be the population of this particular city in 7 years, okay? So that's an example of using an exponential function. Now here, just as when we studied linear and quadratic functions, we talked about a way to figure out whether something was a linear or quadratic from a list. From a list, when we were checking to see if something was linear, we looked at the first difference. We looked to see if that first difference was constant. Did you add the same amount to each time to get to the next y value? When we were testing to see if something was quadratic, we tested to see if the second difference was constant. Well, guess what? We have a different method to test to see if something is exponential. To see if something is exponential, we test to see, first of all, if the x values increase by the constant amount. So I want that x value to be going up by 1 each time, which it is. That's good. That's a constant increase. Now the y values is what's important. I check those y values, and this time for an exponential, I'm seeing if I can multiply by some number each time and that number stay constant. If I can, that is an exponential. If I can't, if I have to change what number I multiply by to get from one y value to the next, that is not an exponential. So to get from 4 to 12, I multiply by 3. To get from 12 to 36, I multiply by 3. And to get from 36 to 108, I know that's multiplying by 3. So since this multiplication here is constant, that means that this function is going to be an exponential. Now if this changes for just 1 second, and let's pretend that this times 3, let's say I had to multiply 12 times 4 to get to 36, even though we don't, but let's say we did. This would not be an exponential now since that pattern of multiplying by 3 is broken. Okay, here's something I would pause the video and write this down or print this off. This just gives you a good graphic display here of what the graph of an exponential function is going to look like depending on whether the a value is greater than 0 or less than 0, and then depending on these two things right here, is the b greater than 0 or is the b between 0 and 1, some fraction in between 0 and 1. So based on those two situations, what your a and b values are in your function, that's going to tell you what the general graph of the quadratic is going to look like. But let's go ahead and look at a couple examples. I want to see what the graph of these two exponential functions is going to look like. So I'm going to go into y equals in my calculator, and I'm going to type in 4 times 1/2, and I'm going to raise that to the x. My exponent is going to be the x. I'm going to graph that and see what it looks like. And there it is. If you match this up with the a and b in the previous slide, you'll see that they have the very same form. Okay, they look just alike. So that is the picture I would draw down on my graph if I was asked to graph this quadratic. Okay, now let's see what the next one looks like. This one's going to be negative, so it's going to look a little different. I have a -1 on the outside, and then in my parentheses, I have 5 raised to the x, raised to my exponent of x. I'm going to graph that one, and I know it's going to look different because my a value is negative this time, and here my b value is greater than 1. So this one's going to have a very different look. It's going to be below the x-axis this time instead of above the x-axis. Okay, so again, that's what you would draw. Now, let's look at one final example. Here we have a situation of someone buying a car. They bought the car for $12,330. That's the original amount. And then we want to figure out in how many years since owning this car that you originally paid $12,330 for, will the car be worth $2,000? So let's think, am I going to plug in 2,000 for x or for y? Well, if we look at the problem, it clearly says that x is the time in years. So I know that the 2,000 can't be the x, so the 2,000 has to be the f of x, which is y. So if I plug this exponential function right here into my calculator, I could pull up a table and see when will the y value be 2,000. So that's exactly what I've done. I've plugged that quadratic into the graphing calculator. Here's a picture of the table, and I am looking for when is y equal to 2,000. Well, it's never exactly 2,000 on my table, but it's in between 12 and 13, definitely closer to 13. So if I had to give an answer, I would say x is 13, x represents years, so after 13 years, the car will be worth $2,000. All right, guys, that is it. Make sure you have these notes copied down, and I'll see you later.